What's up, guys, and welcome back to my. I totally forgot to change out of my workout clothes. Give me 1 second. Ah, much better. All right, welcome back to my YouTube channel. And now that I'm comfy and I've got my dragon onesie on, we can resume our study guide. So, for my class, your homework packet, you're going to need this. It's the blue one, okay? And we're going to go over to the Unit 8 review. You're just going to flip this first page over, and it's the first thing here. And I know that you guys worked on this with Ms. Carrick yesterday, but you guys and I are going to start on question number 15. So go ahead and pull that out. I'm going to go ahead and piece out on this screen right here. And I want to draw your attention to the third page. And let's go ahead and get started with question number 15. So I'm going to go ahead and zoom in here because last time I didn't think it was that clear. So finding the area of each shaded region. So this is going to be a little different. So there's a couple of different ways that you can do these, but in my opinion, the easiest way is to encase your shape in a bigger shape, and then we'll just take out the pieces. So for example, I just encased it in a bigger square here, and what I'm going to do is I'm going to find let me go ahead and zoom out here, color and thickness. Let's go here. So I'm going to find the area of the big square and subtract. It looks like there's 1, 2, 3, there's 4 triangles. So subtract the area of 4 triangles. So let's go ahead and do that. So be careful because each square on the grid is 2 units. So let's see. So then that means this whole length right here is 2, 4. This is a 6. This is 2, 4, also 6. So this is 6 by 6. So the area of the big purple square is 6 times 6, which is 36. And we're going to subtract 4 times 1/2 base times height. So now all of the smaller triangles that I'm about to highlight, so these yellow triangles, these are all right triangles. And they all have the same dimensions. So that's why I can just find the area of one and multiply it by 4 to figure out what all 4 of those are. So the base of one of those triangles is 2 because each square on the grid is 2 units, and the height of those right triangles is 4. So we really have minus 4. Let's see, 1/2 times 2 is just 1, and then 1 times 4 is 4. So we really have 36 minus 16. And then we can go ahead and do 36 minus 16, and that's going to get you 20. So the area of the shaded region is 20 units squared. Okay, now we're going to go ahead and scroll on over, and we're going to find the area of this parallelogram. So remember, area of a parallelogram is base times height. Now, what's nice is that I'm going to go ahead and take advantage of this vertical line here, and I don't want to I want to take advantage of this vertical line here because what's going to happen if I pick this as my base is I'm going to have to use the distance formula to find this. Then I'm going to have to find the slope of that yellow highlighted line. Then I'm going to have to find the perpendicular slope. And then I'm going to have to count the distance. And you know what? That's just doing too much. So I want to save myself some time. And saving my time means I'm going to take advantage of any horizontal and vertical lines that I see on my picture. So I'm going to call that my base. That's going to be my base. And I can count the distance from there just by counting the y's. So the distance between 5 and -3 is 8. Or you can also do 5 minus -3, and that gets you 8. So 8 is your base. Then we're going to go from the vertex of one of the vertices, and we're just going to draw a horizontal line. Okay, and we know that that line is perpendicular. Now, to figure out that distance, I can just take care of my x's. So I can count the distance from -4 to 7, or just do 7 minus -4, and that's going to get me 11. So 11 is going to be my height. All right, so now for the grand finale, area of this parallelogram is base, which is 8 times the height, which is 11. So the area is 88 units squared. Donezo. Alrighty, let's go ahead and down here. Okay, so find the area of a rhombus with a perimeter of 40 and one angle of 60. I want you guys to kind of hit pause and first of all draw a diagram, and when you come back, we'll get started. Okay, welcome back. So let's go ahead and draw our rhombus. So, wow, it's a pretty good, oh my God, that's honestly the best rhombus I've ever drawn in my life. So 3 claps for Miss Medrano here. Okay, now in a rhombus, if you guys remember, all the sides are congruent. So that means each of those sides is going to measure 10 because the perimeter is 40. So 40 divided by 4 is 10. I also know one of the angles. One of the angles is going to be 60. Now, it doesn't matter where you label this, okay? And so to help us find the area of the rhombus, we want to do, again, base times height because it is a parallelogram. I already know the base is going to be 10, but we have to figure out what our height is. So I'm going to go ahead and draw in a height. Now, if you guys notice, I really hope that when you guys draw this in, you're like, this is a 30, 60, 90 right triangle. So I'm going to go ahead and redraw that triangle out here. So that angle is 60, which means this angle right here is 30, and the hypotenuse is 10. So we're going to reach for our 30, 60, 90 right triangle ratios. So that means this side would be 5. That's going to be your x, and this side would be 5 root 3. So ta-da, we have found our height, okay? And so from there, we can just do our base times height. So it's base, which is 10, times height, which is 5 root 3. And remember, innies stay with innies and outies stay with outies. So we're really just going to multiply 10 and 5. And so that gets us 50 root 3. And that's our area. Units squared. Almost forgot my units. Okay. Next one is going to be a little bit of a doozy. So you might want to give yourself some space here. So the first thing I want you guys to do is to label your knowns. So your knowns are as follows. So let's see. ST is 4 root 3. PS is 5 root 3. Measure of angle M is 45 degrees. The measure of angle T is 60 degrees. And I think that's all they give us. Yeah, that is. Okay. Important thing to notice, this is not an isosceles trapezoid because these base angles are not the same. If they were the same, then we could make our lives easier, and this would be 4 root 3. And then we can do the work to find this other base right here. But since it's not, we're going to have to do a little more work. Okay, let's draw in our 2 heights. Okay, once I draw in my 2 heights, I want to automatically label my known. So that means that if that base measures 5 root 3. Guess what? This chunk down here is also going to measure 5 root 3. So I'm just going to go ahead and write that in. So this is 5 root 3. Okie dokes. So once again, over here, I've got my 30, 60, 90 special right triangles. Okay. This angle obviously measures 30. Half of 4 root 3 is 2 root 3. Okay, so that's going to be your x. Now remember, to figure out what this is right here, I need to take my x, which is 2 root 3. So I'm going to take 2 root 3, and I'm going to multiply it by root 3 because that's going to give us our other side. Okay, so I'm really doing 2 root 3, which is your x, times root 3, because that's the ratio that follows with the angle that's opposite the 60. All right, so when you've got a root 3 times a root 3, guess what? That's just a plain old 3. So that becomes 2 times 3. 2 times 3 is 6. So that means this height is 6. And guess what? Your life just got a little bit easier because this height is also 6. And look at that. On the other side of the trapezoid, you've got a 45, 45, 90 special right triangle. So if the height is 6, this is also 45 degrees. That means this piece is also 6. And this side of your trapezoid must be 6 root 2. I don't know why it just erased right there. Okay, now I've got all the information I need. So Let's go ahead and find our perimeter. So we're just going to go ahead and add up all our sides. So we're doing 6 root 2 plus 5 root 3 plus 4 root 3 plus 2 root 3 plus 5 root 3 plus 6. So I got those last three terms from our diagram up there. So that's where those numbers come from. Okay, I added them all up. Now I want to combine like terms. So 5 root 3, 4 root 3, 2 root 3, and 5 root 3 are all like terms. And when we combine them, we get a grand total of 16 root 3, and then everything else is just going to follow suit. So our final answer is 6 root 2 plus 16 root 3 plus 6 as your perimeter. And you cannot combine those further because they are not like terms. Okay, let's switch gears a little bit and let's start finding our area. So in order to help us find our area, I need to do 1/2 base 1 plus base 2 times the height. So I have 1/2. My first base is 5 root 3. That's the top one. That's this one up here. Okay. The bottom base is going to be all of these things added together. So your bottom base is 6 plus 5 root 3 plus 2 root 3. And we're going to close the parentheses. And we know that our height is 6. So we're going to go ahead and combine like terms where we can inside our parentheses. This is a like term with this term and this term, so I can go ahead and add those all together. So I've got 1/2, and that's going to be 12 root 3 plus 6. Close the parentheses, times 6. All right, let's distribute that 1/2. Half of 12 is 6, so I've got 6 root 3. Half of 6 is going to be 3. That stuff stays in parentheses, and I still have that 6 at the end. Now I'm going to distribute that 6 inside the parentheses. 6 times 6 root 3 is 36 root 3. And then 6 times 3 is 18. So our area of this trapezoid is 36 root 3 plus 18 units squared. Okay, let's go ahead and turn the page. On the fourth page right here, this question number 19, these are really straightforward questions. If you have any questions on those, you can feel free to pop into my office hours and we can work through those together if you would like, okay? I want to direct your attention to, what is that, like 20C? I think it's 20C. Yeah, 20C. Okay, so we've got this little sector here, and we'll learn about those when we get back to school, but we can see that that's obviously a part of a circle, and excuse my bad circle, but it's a fourth of a circle, right? So our plan, and whenever you guys are finding areas of shaded regions, I really want you guys to get into the habit of making plans. So we're going to take 1/4 of the area of our circle, and we're going to subtract the area of the triangle. Okay, and so now what I want us to do is, let me see if I can do this. Oh, I won't do that. Oh no, did my thing just freeze? Oh no. Give me one moment, guys. All right, and we're back. Sorry about that. Sometimes my computer acts up. Okay, so I want us to go ahead and write down the formula. So I have 1/4 of my circle, and the area of a circle is pi r squared minus 1/2 area of a triangle, which is 1/2 base times height. Alrighty. So this height of the triangle, guys, is also coincidentally going to be your radius of the circle. So we're really going to do 1/4 pi 6 squared, okay, minus 1/2. Your base is 6 and your height is 6. So these lengths are both 6s. And one of the reasons is because both of these things that I just highlighted in yellow are both radii of a circle. Radii of a circle are, in fact, congruent. Okay, so from there, it's really just a matter of doing the arithmetic. So it's 1/4 pi times 36 minus 1/2. 6 times 6 is 36. Okay, 1/4 of 36 is going to get you 9. So we have 9 pi minus 18. and that's going to be your area of the shaded region. So 9 pi minus 18 units squared. I know that looks a little funny to look at because the 18 is bigger than the 9, but keep in mind that pi is 3.14, so you're really doing 9 times 3.1415926 garbage minus 18. So you are going to end up with a positive answer no matter what. All right, let's go ahead and try some of these last ones. So these are area 2 ways problems, and I know I talked about those in my class, but that's just what I call these types of problems. All right, area of a parallelogram, remember, is base times height, and you can designate anything as your base and height as long as they're perpendicular. So I'm going to say that this is your height and this is your base. And so to find the area, we can just do 4.3, which is your base, times 4, and that's going to get you 17.2. Okay, so I know that this is your area of the parallelogram, but they want us to find h. In order to find h, we're going to use our area. So our area is 17.2. We're going to set that equal to our new base, and our new base is going to be 5. 5 times our new height, which is what we're trying to find. So, times h. So to solve for h, we really just have to divide both sides by 5. So 17.2 divided by 5 is going to get you 3.44, and that's your height. Okay, go ahead and hit pause and try the next one on your own. All right, welcome back. So once again, area 2 ways. Here is your base, and here is your height. Okay, and we use that to find the area first. So we do 6 times 13. So this parallelogram has an area of 18 centimeters squared. Now we're going to use that area and set it equal to our new base, which is 4, and our new height, which is what we're trying to find. So new base is 4, new height is h. So in order to find your height, we just have to do 18 divided by 4, and that gets us 4.5 as your height. Okay, and then the last one, same principle. I've got 10 is my base and 7 is going to be my height. So 10 times 7 equals 70. So 70 is the area. And then I'm going to set it equal to 8 times h. So 8 times h equals 70, because 8 times your height will also get you the same area. Divide both sides by 8, so h equals 8.75. Whoops. Alrighty. So this last page over here are all honors problems. I really would encourage you guys to try these. If you want some hints, one of your hints that I'm going to give you here is that this is an equilateral triangle, okay? And we know that the radius of the circle is 3. This angle must be 30 degrees and this angle must be 60 degrees. Now, the reason this one is 30 is because in an equilateral triangle, all angles are 60 degrees. So if we cut it in half, then we get each piece is 30 and 30. So you can go ahead and use your special right triangles to find out what your base would be, because you're going to basically be looking for all of this. Okay. All righty. And if you want to go over that in greater detail, you can just pop into my office hours. Your hint for the next one over here is going to be to draw in a diameter. So that's from one end of the circle going through the center to the other. So this is 6 and this is 6. Okay. And then this is 6 and this is 6. Okay. I'm not going to give you any further hints other than that. If you have any questions, feel free again to reach out. I will point out one last thing. These two triangles that I'm highlighting here are equilateral triangles. Think about the angles that they create, guys. You're going to need that. All right. I am going to do number 23. So if you're curious on 23, then stick around. If not, you can just move on. Okay. So we know angle PQST is a parallelogram. Okay, cool. So I need that information. Angle P is 60 degrees. Oh, and guess what? Opposite angles in a parallelogram are congruent. So if angle P is 60 degrees, that means angle S must also be 60 degrees. PT is 12, and in a parallelogram, opposite sides are congruent, so this side must also be 12, okay? And then they give us a ratio. So this is saying that the ratio of WS 2ST is 2 to 7. Okay, so let's go ahead and figure out what we know. And so what we know is I can use my 30, 60, 90 right triangle ratios to help us figure out some of the sides in this triangle over here. So if the hypotenuse is 12, WS must be 6, QW must be 6 root 3. Okay, so I know the height of my parallelogram. Now I need to figure out what my base is. This is where that ratio is going to come into play. They give us a ratio that says, hey guys, WS compared to ST is 2 to 7. Okay, so we're going to set up, guess what, a proportion. And I'm going to put WS in the numerator and ST in the denominator. So WS goes with the 2. And we already know that the length of WS is 6. So in my proportion, I'm going to set the 2 over 7 equal to 6 over. I don't have anything for TW, so I'm just going to leave that right now as X. I'm going to designate that as X. But the thing is that the ratio is not comparing WS to TW. It's comparing WS to ST, which is this whole bottom part down here. Okay. Now, the way that I would express that is I would just do, 6 plus X. So I would do 2 over 7 equals 6 all over 6 plus X. Okay, I've set up my proportion. Now I'm going to cross multiply. So 7 times 6 is going to get you 42 equals 2 times 6 plus X. Go ahead and distribute that 2. So you got 42 equals 12 plus 2X. Subtract 12 on both sides. So we get 42 minus 12. And that's going to get you 30 equals 2x. Divide both sides by 2. And that gets you x equals 15. Now be careful. 15 is just this blue part that I highlighted. Okay. Which means that this green part is going to be 15 plus 6, which is 21. So that green part is 21, and that's going to be your base. This is important, right? Because we need our base to help us find our area. So area of a parallelogram, or area of PQST, is going to be base times height. Your base is 21. Your height is 6 root 3. Innies stay with innies. Outies stay with outies. 21 times 6 is going to be 126, and that root 3 is just going to follow. So the area is 126 root 3 units squared. All right, guys, if you like this video, make sure you like, subscribe, and comment down below. If you have any questions, feel free to pop into office hours. And yeah, hopefully I'll see you around in the next one.